Every year, rockfalls and slope failures in open pit mines put lives, equipment, and productivity at risk. Our solution brings cutting edge AI and real time monitoring to make mining safer, smarter, and more sustainable. We Phoenix present our prototype Drishti. So basically, this is our landing page of our website. It contains all the necessary accessibility features you need in a website, like language conversion, font size change, etc. To go to the dashboard, you just have to click the dashboard button and you can go to our main dashboard. In the dashboard, you can see live sensor monitoring as well as an interactive map. In an interactive map, you have to put in the coordinates of a mine you want to make the prediction. This is a very simple and user-friendly interface. It automatically fetch all the data from the satellites required for predictions like DEM, rainfalls, post-vegetation elevation, etc. Total considering of 18 parameters. You just have to draw the polygon over the mine area you want to make prediction and click on export geotiff. It will take around 2 to 3 minutes to conquer all the data. After the data has been gathered, it will got downloaded in your laptop. After it is downloaded in your laptop, you can just go to our analysis tool where you will find many analysis options like 3D DEM risk map. So what does the 3D DEM risk map show? It shows all the areas in the mine where slope failure or probability of rockfall is maximum. The purple area shown here is the area where the probability of rockfall is maximum. Now comes our next feature, 2D heat map. The highlighted area here shows the areas which are at the most risk of a rockfall, which also matches our 3D heat map. Now comes our next and one of the most important feature, which is our XGBoost model, which does the prediction of rockfall in open pit mines. You just have to add the parameters here and click on run batch analysis. After the analysis is complete, you can see medium risk. So the mine is at a medium risk or 57.65% risk of a rockfall. Now comes our drone imagery data. So this is a CNN model in which you just have to put in the drone captured image file. After you have put the drone captured image file, it will automatically check for cracks and rocks. After it has identified, it will make the prediction of a rockfall. Here it's 77.1%. Now, as we have studied about rockfall, we came to know that rockfall is directly proportional to seismic vibrations. So we can use the recent stations or the live seismic waveform that is provided by nearby countries or India, which is shown here, which is monitored live by our model as well as our backend, central backend and website. Now during our research, we found that false negatives are very important in mining, as false negatives can put people lives at risk. So we came up with a solution, reinforcement learning. So what does reinforcement learning do? So it basically learns as you do more prediction with the model. So how so basically if you do more and more and you use this model more, it will get better over time. So basically you just have to put in all the parameters here, and after it runs the reinforcement learning model, it will give a detailed analysis result of all the parameters of the mine. Here you can see that the probability of failure is 3% in this mine, along with all the probability of failure distribution map, cohesion sensitivity analysis map, friction angle sensitivity analysis map. So this is one of our state of the art features where it learns over time, it gets better as it makes prediction. So it conquers the false negative features. Now, next comes our physics analysis simulator. So what does the physics analysis simulator do? You just have to put in a DEM file all the parameters required like trial, speed, depth, slope, threshold, mu mean. It will predict the trajectory of rockfall. What do you mean by trajectory of rockfall? Basically, the path taken by the rocks when a rockfall occurs. So it will predict that, as well as the path taken by the rocks, as well as the impact energy or the kinetic energy of rocks during the particular path taken or a certain point of a rockfall.
So now I will be showcasing the working of hardware for our project. So our hardware mainly consists of a servo mounted LiDAR sensor which detects any kind of rockfall or any kind of object in front of it. An LVM 393 sensor which is used to detect rainfall and humidity. An MPU 6050 sensor which is used to detect vibrations. An EMP 280 sensor which is used to detect temperature and pressure changes. All of this is connected to our Arduino board, which is further connected to my laptop, which is used to send data to our API over Wi-Fi. Once the API receives the data, it sends alert to both our Android app and website. So let's check for alert on our Android app. As you can see, currently there are no alerts. Now as soon as I put my hand in front of our LiDAR sensor, it should send alert to our API, which further sends alert to our mobile app, and the buzzer goes off. Now as soon as I remove my hand from my in front of the LiDAR sensor, the alert goes off and it says no rockfall detected. So this is the working of our project. Thank you.